Hi everyone. In this video, we are going to learn about primitive data types in Java. In this context, we can classify our data into numbers, boolean, and character. Numbers can be further divided into whole number and numbers with decimal places. Let's see what are the data types available in Java to store these values. A whole number can be stored by using byte, short, integer, or long. Decimal numbers can be stored by using float or boolean is a special data value which is used to store values like true or false, and the data type available to store a boolean is boolean. A character or a letter can be stored by using a data type called char. Let's start with whole numbers. We just saw there are 4 different types of primitive data types available to store these numbers. Each of these data types supports different range of numbers to be stored. Let me start with byte. I'm just declaring a variable called a byte variable which is of type byte and assigning a value to it. If you guys are very new to Java and don't know what a variable is and how to declare one, I would recommend you to watch this video. In the comment section, I'm going to give what is the range of value which is supported by a byte data type. The range of value what it supports is -128 to 127. Let's see the range of values supported by other data types as well. Each of these data type will consume some memory when we create one. Let me show you how much memory each of these data types consume. A byte, as its name says, it will consume 8 bits. Short is a 16-bit data type. Integer consumes 32-bit and a long consumes 64-bit. Now you may notice the range of value supported by any of this data type has some dependency on the amount of memory it occupies to store a value. Let me show you how to compute the range of the value based on the memory size these values occupy. Suppose if n is the number of bytes required to store a value, then the range is derived based on this formula, which is -2 to the power of n minus 1 to 2 to the power of n minus 1 minus 1. Let's apply this formula on byte. We know a byte is a 8-bit sized variable. So if I apply this -2 to the power of n minus 1, which is 8 minus 1, 7, to 2 to the power of n minus 1, again 7, minus 1, I get -128. So the other side of the range is +127. Same thing we can apply for integer and check if it stands true. Now you might be wondering, if there is a long data type which can support a bigger range of value, what is the purpose of other data types? Right. Say if I were to store a value 128, I can directly put in long. What is the purpose of short or integer? There is a significant difference, especially in terms of memory consumption, when we choose the right data type. Let me demo this with a simple example. Here I have created a custom type called township, inside which we have a instance level variable called population, and it is of type integer. Now what I'm going to do is I'm going to verify how many number of these township objects could be created in a given heap space. A heap space is a part of a memory location where all the objects getting stored to when the program executes. For this, I'm going to create a simple collection and I'm going to iterate infinitely And during each iteration, I will create one new instance of township object and add it to the collection. I will also print the count so that when the program comes to an end, I will get to know total number of objects created. If you're not already aware of this thread.sleep, don't be concerned. For time being, just assume that it will pass the execution for 30 seconds. This is just to give me a buffer so that I can launch a profiler and connect to the program running. Otherwise, once when it starts creating the instances, it is an infinite loop, and there is a challenge in getting the profiler establishing a connection to the running program. So don't be concerned about all those things. Just focus on the point that we are trying to create objects and see how many number of objects we could actually create in a given heap space. Before launching the program, I'm setting the max heap space explicitly as 256 MB. Yeah, I've set it, and let me launch the program. Yeah, the program is launched. Let's bring the profiler and see. Yeah, it has established the connection. For this experiment, we are interested in the memory, so let's uncheck the other parts like CPU threads and all. Yeah. Now the objects have started creating. You can see in the console it is printing the number of objects it gets created. Let's wait. And here in the profile you can see the heap space consumption is growing. Yep. The program has abruptly terminated with the error saying out of heap space. Yeah, that is expected here in this case, as we are not letting the objects to garbage, getting garbage collected. So let me log the number of objects which got created, which is roughly some 13 million, I could see. Now I'm going to do a simple change. I will change the data type of the attribute population from integer to long. And let's run the program again and see how many number of objects we could create. Pretty much everything the same. Profiler launched, and we are monitoring the memory. Yeah, the program is terminated now. Let's see the total number of objects we could create now, and definitely less than the previous run. Let's compare the numbers. So we could approximately create 4 million records less than the previous attempt. So this is the main purpose behind having multiple different data types. In fact, like, this is not the ideal way to compare the memory consumption, but it would definitely give a rough idea of what is the significance of choosing the right data type. Let's go and see the internals, how the values are getting stored in the memory. I've written a simple utility to represent the binary form of these values. I'm going to use that method and print the values. Let it print all the 4 data types, byte variable, short, int, and long, and see how the value gets stored. So all of them currently, all these variables, stores the value 1, and here we go. It's how the 1 will be represented according to the data type which has been used to store these values in the memory. If you remember, when we look at the formula for computing a range, we used n minus 1 when n is the total number of bits. Why we are deducting that one? The reason is, here the leftmost bit is used to represent the sign of the number, because all the primitive types in Java are signed. It means they can store both positive as well as negative numbers. So the computer should know whether the given stored number is a positive number or a negative number. That is been indicated by the leftmost bit. 0 represents positive and 1 represents negative. So let's see if I go and try to print the binary representation of the number 2 and minus 2. Yeah, here do you see the minus 2, the MSB becomes 1. Let's move on and try to find why we have to have a data type to represent a number with decimal places. So what I'm going to do is I'm dividing 4 divided by 2. So the answer is 2. Fine. Let's divide 3 by 2. The expected answer is 1.5, whereas what we got is 1. The reason is, in Java, the literals are integer by default. I mean, the number literal without any decimal place is integer by default. So when we divide 3 divided by 2, we get the result 1.5. But since 1 being an integer, implicitly it is an integer, it cannot represent the decimal place. That gets truncated. It means it is lost. Here comes the data types like float and double to save us. Let's do the same division, but this time instead of using integers, I'm going to use a float literal. Float consumes 32 bits of storage, so that determines the number of decimal places it can represent. Here you see, now we got the expected result 1.5. Let's see the number of decimal places which could be represented by using the float, for which what I'm going to do is I'm going to divide 1 by 3. Decimal values by default in Java are of type decimal. So to make it float, we have to use the value f next to the literal. And here you see, when we divide that, we get approximately some 67 decimal places. What if you want higher precision? I mean, you want more decimal places. There comes the data type called a double. So double will consume 64 bits of memory, and you would be able to get little more extra precision compared to float. See, the same number 1 divided by 3, it gave a more precision with double data type. So depending on the level of accuracy you need, probably you need to choose either float or double. So there is one problem which we all should be aware of. Because of the way the float and double values are getting stored as binaries, they cannot exactly represent the actual precision. It could be easy to understand if I give it with a demo. I'm going to subtract 2.5 from our value 3.1. So the result what we expect is 0.6, right? But let's see what result when we get when we use float and double. In neither case, we received 0.6 exactly, right? That is a minor, though we get a value which is closer to 0.6, but that is a minor difference, and it can play a critical role, especially if float and doubles are used for computing, currencies and other stuff where all this precision matters. So what is the solution here? The solution is we have a data type called BigDecimal. By using a BigDecimal, we can achieve the precision to the number of decimal places what we want. Let me quickly show that to you. So here we got the desired result, right? Being an object, a BigDecimal will consume little more extra memory compared to the primitive data types. So there is a trade-off between like what we want. Suppose if we want to do a lot of computation in much faster way where precision, higher precision is not required, we can settle with one of these primitive data types. If you want highly precision rounding and the number of decimal places, especially in a controlled way, then we have to go for BigDecimal. And so let's move on to character. Char is a data type which is used to represent a single character. Here the literal value we have to give in single quotes. What if we need to represent more than one character? It can't be represented as a primitive data type. Instead of that, we have a custom type called string. A boolean value can be represented by using a boolean data type, and the accepted values are true and false. Make a note, there is no quotes here. If you put a quote, it will become a string and your compiler won't be happy. So now we have pretty much covered all the primitive data types, and let's see what are the different ways we can represent these values. When it comes to number, the whole number, it could be represented in as base 10 or base 8, base 16 and base 2. We are going to represent the same value but by using different literal formats. Base 8 always starts with 0. And base 16, which is hexadecimal, starts with 0x. And the binary starts with 0b. And let's print the values, and you see we could see all these values could give us the same value 25. And in the recent version, they have added supporting underscores to increase the readability. So you can see a big number. To increase the readability, we can put underscores between the numbers. It doesn't have those underscores doesn't have anything to do with the value itself. It will not change or affect the value. Literals with underscore are supported in both integer as well as in floats and big decimals. When it comes to character, we can also use Unicode literals, which always starts with slash and slash u. We have pretty much come to the end of this video. But before signing off, I would like to explain what would happen if we try to assign a value which is beyond the range supported by a given data type. Let's take byte. Byte supports a range of -128 to 127. Now I'm going to create a variable of type byte and assign a value 128, which is outside its range. Yes, as expected, the compiler is complaining that the value cannot be accommodated in a byte variable because it's outside its range. What I'm going to do is I'm going to downcast it. When I do a downcasting, the compiler is happy. But do you think the value what actually got stored is 128? Definitely not. The value is -128. The reason is when I do a downcasting, what happens is the MSBs which are outside the range, which is 8 bits, gets truncated, and this is the final binary representation of the number which gets stored. When this gets interpreted into the actual binary number, decimal number, that is nothing but -128. So we should be very careful when we try to assign a value which is beyond the range of a given data type, especially when we do downcasting, because you may get an undesired result. That's it, guys. We have covered pretty much everything related to primitive data types, and when to go for decimal data types like float and double, and what is its limitation and what is the alteration, and what are the different literals, and how can we improve the readability by using underscore while using literals, and what measures we need to take care, especially when we are downcasting a number. That's it, guys. If you haven't subscribed to my channel, please subscribe. If you like this video, hit on the like button. I will meet you soon with my next video. Till then, bye bye from Yuva.